Hello, everybody. We'll give a couple minutes just to let some people fill in. Hello, everybody. So we will go ahead and begin. Happy to have you all here for our official LiMobile M2 global launch. We'll jump straight into it and start with the promotional video. Great. So as you can see in the promotional video, we've made a major step up from our LiMobile M1 series, and I hopefully can highlight some of those features for you today. So we'll begin with the contents, pretty much a product introduction similar to the promotional video, workflow for the system, and then some industry application uses. So to begin the product introduction, we have two different versions currently of the LiMobile M2. The first system is utilizing the Hesai XT32 M2X, which has allowed us to push out the distance for the sensor from 120, which was our LiMobile M1, to a distance of 300 meters with the XT32 M2X. Both of them have the capability of utilizing the Ladybug 5 Plus, and we've also added the option for the Ladybug 6. Some of the key factors between the difference between the M1 and the M2 is our ability to add our own self-developed SLAM algorithms to allow the system to work in GNSS denied environments, where the LiMobile M1 and some of our competitors would potentially fail in processing. So urban areas, forested areas, tunnels of the such. The second version of the LiMobile is the LiMobile M2 Ultra. Everything about this system is pretty much the same, except for the Ultra has the Regal Lux 1HA, allowing for millimeter accuracies, getting better pavement analysis, better IRIs, and an overall deeper system for road condition analysis. So as you can see, what I mentioned before, the Ladybug 5 Plus is highlighted here. We have our front-facing LiDAR sensor that's tilted at a vertical slant for collection purposes, and then we have our horizontal-faced SLAM LiDAR, both XT32 M2Xs. We have reduced the weight of our roof rack system, making it easier and more manageable for a single individual to put onto the vehicle. We've added additional mounting plates to make for a more stable system altogether. And we've also added a additional battery to the system to add to the battery life or daily battery usage. So as we can see, some of the highlights, as mentioned before, the M1 was only capable of ranges of around 120 meters, where adding the XT32 M2X has pushed that out to 300 meters. The data points are roughly about the same as before, but the quality is a bit better due to some of our recent breakthroughs in our algorithms. Multiple shapes and freely optional, so users can freely choose external sensors such as the Ladybug 6. We also have a planar camera setup, so up to 6 or 12 cameras that you can add to the system for pavement analysis and front-facing view for sign detection and facility management. And we also have enhanced our DMI for better accuracies. So the system itself with DMI and SLAM is a full all-in-one solution. This system, compared to the M1, has a highly integrated flexible installation, including the ability to change the angle of the system from 0 to 15, 30, and 45, allowing for side scans, sidewalk scans, and additional angles for future use cases. It's easy to handle complex scenarios utilizing LiDAR SLAM, GNSS, INS, and DMI. Instant insight total control. So we redeveloped our app for the system, real-time monitoring of the data and the location data, among some other features. And then AI drives multiple industry applications. It is widely used in GIS assets, urban power senses, and urban landscape and other fields. So as you can see here, what we're highlighting is the difference between the range of the M1 and the M2. On the left-hand side of each of the images, we can see that the extent is around 120 meters for something like the Golden Gate Bridge. The M1 was incapable of reaching the top of the tower, which left out some of the facilities, which in turn made it so that the point cloud was incomplete, where the images on the right-hand side highlight the heights of buildings and also the height of the tower itself, showing that the M2 with the XT32 M2X reaches a much greater height, getting a better coverage first time around so that you don't need to scan twice. As mentioned, we have offered a planner camera option. In the past, the M1 had an embedded camera, a single planner camera that was facing backwards. It was useful for RGB colorization, but had a bit of drawback when it came to any of the other functions, including our deep learning image classification. So now we have pavement cameras focusing on the road surface for a detailed pavement analysis, and then also a front camera that captures traffic signs at high resolution. As mentioned, we also have the option for the Ladybug 6 to obtain higher resolution panoramic cameras, images at 72 megapixels as a total panoramic image. And then our DMI provides assistance when satellite signals are blocked or unavailable, improving system stability. Along with the use of the SLAM, you have a much better chance of accurate data at the end of the day. So clear images detailed. This is just highlighting on the left-hand side the difference between the quality of a Ladybug 5 Plus camera and the Ladybug 6 on the right-hand side. On the top left, we can see that the cameras themselves, the street cameras, are a little bit blurred, where with the 6, the detail is more fine, leading to better results. Same with the McDonald's sign. We can see a bit of strong quality from the 5 Plus, but a bit of greater resolution coming out of the 6 Plus. And then on the bottom left, we can see that the color differences between the two systems show greater detail with the Ladybug 6. If this is necessary for your clientele, then it is suggested to choose the Ladybug 6 because it is the latest of the Ladybug fleet of products. So some of the key factors that we had mentioned that make the difference between the M1 and the M2 is the SLAM and the DMI function built together. So comparing the trajectory data on the left-hand side and on the right-hand side at the top, we can see the difference between the DMI results. So on the left-hand side, not using DMI in a highly forested area, which led to GNSS trajectory offsets, where using the DMI led to a much more accurate, much overall better trajectory correction, improving accuracies by up to 70%. And then on the bottom, we can also see the same similar outcome. This is in a parking garage. The SLAM, without SLAM on the left-hand side, because it was pure GNSS denied, the data pretty much is going to fail. Where on the right-hand side, utilizing SLAM, we are able to see that the data was able to process correctly without any GNSS coverage at all, and leaving an area with that was prevented from obstructed but feature-rich. These are just highlighting some data sets. They were supposed to play, but we'll just move on past that. From the left, we can see the RGB colorization of a data set. On the right-hand side, we can see as viewed by height in a tight confined area with less satellite coverage. On the bottom left-hand side, we can see a very complex interchange. It is suggested with interchanges that you do individual routes of each interchange just to make sure that you get full coverage. And then on bottom right was a highlighted video of a tunnel. The tunnel was able to correctly adjust for the offsets of GNSS when using SLAM. This is just highlighting. No, the videos are fine. This is highlighting the ability for the system to turn. So as I had stated, it has the ability to go from 0 to -45 and 0 to +45. These are all fixed adjustments and can easily maneuver prior to the collection. So this is highlighting the total control as mentioned before. Again, these all should have played. So supports real-time preview of point clouds and images, both the planner images and the panoramic images, along with the LiDAR. It supports import of planned trajectories, meaning that you can pre-plan your trajectories and import that KML file and follow it as needed. It is recommended to divide the trajectory according to the survey area just to get the best result. It supports the display of real-time acquisition of trajectories. It supports trajectory playback as well, so being able to see what you had already done to make sure that you covered the areas that you were supposed to cover. It supports online map downloads, so you can download map packages directly from the device prior to going out and collecting in case you are to lose data so that you don't have an accurate base map. That allows for preset map download. Real-time monitoring of the system status. That includes the battery, the location, the GNSS offset, PDOP, allows for seeing the total overall status again of the system in operation. And then process-based acquisition steps have become much simpler and easier to learn. And it also supports a voice broadcast. So again, highlighting the difference between our changes with the M1 to the M2. So I'll start with the XT32M2X. It is a much better sensor. It has a much better range, and it is overall leading to a better accuracy and also result when it comes to utilizing for SLAM. Where the Regal Vux 1HA, we did not have a M1 Pro that we released publicly that utilized this system. So we enhanced the system to suit the M1 Pro, to suit the M2 Ultra, utilizing the Regal Vux 1HA, which has a scanning range of up to 475 meters. So you have a much greater range, much better accuracy at a higher price ticket point, but still lower than that of our direct competitors. In terms of the SLAM LiDAR, it is used in both the M2 and the M2 Ultra, both mainly for the purpose of GNSS denied environments. Both systems have the option for Ladybug 5 Plus. Both the M1 and the M2 had this option. Only the M2 Ultra and M2 have the option for the Ladybug 6. Both the M2 and M2 Ultra have the option for our planner cameras, both the pavement one and the front-facing one. It's 24 megapixels per, where the M1 did not have this option. It just had that single planner camera in the back of the system that would face backwards for RGB colorization of the point cloud. With the M2, you can use the panoramic cameras for RGB colorization, leading to a better overall RGB colorization of your data. The M1 only supported a time camera trigger mode, where the M2 supports a time and distance trigger mode, leading to better resulting images for deep learning image classification. The working hours for the M2 with the battery system that we provide is 2 hours greater than that of the M1, but this is reduced when utilizing the M2 Ultra due to the sensor's high power needs. The system architecture is ARM for the M2, where it was the 86 for the M1. The collection software for the M2, as mentioned, is our new self-developed Green Valley app, where the M1 was a web-based system, which may or may not have had issues leading to disconnection of the interface when in use, which shouldn't have impacted the data, but it could be timely for an individual to feel that they need to pull over to make sure that the system is working correctly. Now they have it on a provided tablet that it comes with the system so that the user can feel at ease when driving and operating in intense environments. And then the processing software before for the M1 required first pre-processing within LiGeo reference and then moving to LiDAR360MLS for post-processing and feature asset extraction, where now with the M2 system, everything is built into LiDAR360MLS, which makes an extremely smooth transition between the pre-processing and post-processing. No need for two separate softwares anymore. So some of the specifications that the M2 has is that the sensor overall dimensions are much smaller collectively than that of the M1 due to the distance between where the Ladybug was set up and the unit itself. The sensor unit weight is around 14 kilograms. This is with the Ladybug. It has two external removable drives of 1 terabyte each, and it has a battery capacity of 6,000 megahertz times 6. So each of them are independently operated and can be powered on and off through the on-off switch that is on the power device, which was not the same with the M1. The typical power consumption is around 75 watts, and the power supply input voltage is 24 volts, which means that the device can be plugged into your vehicle's battery if you need to collect at a longer rate. If that is the case of what you plan on doing, please let us know in advance and we'll give you the best practices or the best platforms in order to achieve that. The operating temperatures are between -10 degrees Celsius and 50 degrees Celsius. In terms of the Ladybug's camera options, the difference between the two is that the Ladybug 5 Plus has 30 megapixels with 5 cameras with 6 sensors, 5 megapixels each per of the 6 sensors, where the Ladybug 6 is 72 megapixels in total, so 12 megapixels per each camera and their 6 sensors. The maximum frame rate of the Ladybug 5 Plus is 10 frames per second, where the Ladybug 6 offers 5 frames per second. And then the overall resolution is higher with the Ladybug 6 than that of the Ladybug 5. Both of them do have the option for the time or distance triggering. And then the pavement cameras are from us, and those are 24 megapixel cameras, so 12 megapixel by 2 sensors. And each have the option for either 5 frames per second or 3 frames per second, and also the time and distance trigger. The LiDAR specifications for the XT32M2X has a range accuracy of 1 centimeter, field of view of 360 degrees, and a vertical field of view, so horizontal of 360 and a vertical of 40.3. The data points generated is about 1.28 million points per return at dual return. And again, the range is around 300 meters, so 5 centimeters to 300 meters. And then in terms of positioning, we have our GNSS system, which can utilize satellites from GLONASS, Galileo, Baudos, and QZSS and SBAS. IMU update frequency is around 100 hertz. And then the mechanical DMI is the mechanical wheel odometer for road applications. Positional accuracy within RMC is around a horizontal of 1 centimeter and a vertical of around 2 centimeters. The roll pitch accuracy is around 1 degree, and the heading accuracy is around 4 degrees. In terms of the M2 Ultra, I'm just going to highlight the difference in the weight. So weight and battery. So the weight is around 18 kilograms. So it's about 4 or 5 kilograms heavier than that of the XT32 version, just due to the sensor size. It has an IP65 protection rating. So it has a lower temperature, operating temperature at 40 degrees Celsius instead of the 50 degrees Celsius. And it has an absolute accuracy of plus or minus 3 centimeters. Collectively, the sensor itself has an accuracy of a precision of 3 millimeters, so a thickness of 3 millimeters, where the XT32M2X is going to have more of a 1 to 3 centimeter accuracy or precision of thickness in the point cloud. Scan speeds are 10 to 250 scans per second at a 300 kilohertz pulse rate. And again, range is around 475 meters. Everything else is the same. So key differences between the two is just what you're looking for in terms of precision and in terms of accuracy between the two sensors. So now I'll jump straight into the workflow operations. So as a company, we want to make sure that if you purchase our systems, you have the best results without having to go back and forth between support needs and any issues that may arise. So the very first thing that we suggest to all clients is doing a field investigation. So investigating the actual traffic conditions of the road section to be tested, including but not limited to objective traffic congestion, vehicle speed limits, whether main and auxiliary roads can be collected, traffic restrictions, and others. Investigating the satellite signal reception in the measurement area, specifically and mainly in the time of doing your initial calibration or the initialization at the beginning and the end. Having a very strong coverage at those 2 points can lead to a better overall result. More than 15 satellites are required for the initialization position. search of the equipment, inertial, and navigation. So in the beginning, make sure that you're seeing at least 15 satellites. So I would always suggest to do your initialization in a very wide open area. This will, again, just lead to a better result and a better accuracy. Determining the scanning range and object. So making sure that whatever you're trying to scan is within range of the 300 meters. Typically, we would suggest around 120 to 200 meters to make sure that you have that coverage. But in instances like the images I showed before of high buildings, you can still feel comfortable knowing that a building that is under 300 meters will still be captured. So just make sure that if you're needing heavy detail of a 200-story or 200-meter building, which is uncommon, that you will be able to get it from the correct angle that you are driving toward or driving against. Marking the map for corresponding prompts, such as driving route directions, turns, connections. So still suggested not to do to drive in reverse. So make sure that if you have roads where you have to do a dead end, that you pre-think those through. And with the system, you do have the ability to pause and play, but it does not stop the trajectory from collecting. So it is still suggested not to do returns. If you need to do a 3-point turn, that is suggested that you are capable of doing that. But typically, we would suggest doing a U-turn and then finding a relatively suitable location for setting up base stations and planning a certain number of target point locations. This is also another critical piece of advice that we suggest to our clients. So this one is pretty much highlighting the second step, which would be the target points. So the whole purpose of this is to correct the positioning errors of the equipment. So although we have added the SLAM and we utilize the DMI, there can still be errors just based off of the system and IMU accuracies based on whether or not you have poor cloud coverage, poor satellite in certain areas. So we always suggest collecting strong amount of ground control points. So reducing the impact of cumulative error on the measurement results and thus improving the accuracy of the data result. This is an indispensable step in the operation. So target point type, road marking corner points. So anything that is a corner point on a road, specifically something that has high reflective spray paint, is one of the best options. Chessboard target points, crosswalks, turn lanes or turn signals. Those are all good options for ground control points. You do want to put the ground control points in the scanning path of the device. So whether it will be where you directly drive over or very close to the area that you would drive over. And then the specifications are that the target point should be appropriately encrypted in places where the satellite signal will be lost. So if you need to make sure that you go out and collect control points, you don't want to go out and collect those control points in wide open areas. You can just for your own safekeeping, but the key suggestion is to make sure that you're doing these control points in areas where it is likely for you to have GNSS failure or a low level of satellites. The reason why this is because when an error occurs in trajectory, it's highly likely to happen in those areas. So having control points in those areas will help correct that issue as much as possible. And then surveying instruments, we suggest either using an RTK device or a total station or a mix of the both. As you can see on the bottom, limited sky visibility of 50 to 200 meters. In the tunnel, 50 to every 100 meters. And then in open sky, you can range between 100 and 500 meters between each of those control points. So the key factor here that we're highlighting is the tunnel and the limited sky visibility, making sure that you're keeping those control points as close as possible. That way that the result can improve drastically, where if you were to take control points at a very large gap between them, you may have issues that arise just purely from the offset in your control points. And then the next biggest feature or function of the workflow that we suggest for you to take into consideration is the sparsity of point clouds. So a 3-lane, 2-way vehicle needs to be driven in the middle of the lane. So if you have a 3-lane, two ways, you want to make sure that you drive in the middle of the lane so that it's able to capture everything the first time around. A 4-lane, 2-way vehicle needs to be driven in both directions and scanned twice to collect enough laser points. It is possible to collect a strong amount of data by doing each direction one time, but for safekeeping, for purposes of a highly detailed feature object urban environment, it is suggested to do 2 passes. Your typical highway scan of 0 features but heavy traffic, it is also suggested to do twice, just so that if you have a lot of people or a lot of vehicles in the pattern the first time around, you may have a better chance the second time around to get more data, because as we all know, LiDAR cannot see through vehicles, it cannot see through objects. So just to make sure that you save yourself from having to go out 2 months later or a month later, just do it the first time around. So factor that in. And then a 6-lane 2-way vehicle needs to be driven in both directions and scanned multiple times to collect enough of the laser point clouds for the exact same reason as what I had suggested before. And choosing the same trajectory line is okay, but it is suggested to do an offset. So if the first time you go, you're on the right-hand side of a 6-lane, second time you do the inner side of the lane, or you can choose to do each of the lanes if it's going to be that you do that same path 3 times over. The software will indeed take the data itself and correct it and make sure that it utilizes the best amount of points to get a single point cloud that is as dense as possible. And then considering the problem of occlusion of the middle isolation belt or green belt in the lane, if there is an occlusion, the 2-lane, 2-way vehicle needs to be driven in both directions and scanned once. So if it is a single or a 2-lane or a single lane but has a middle island, it is best to drive that path once on both sides, but you should not have to do it more than once. And then considering the data accuracy requirements, we do say to avoid left and right turn collection in terms of heavy right, heavy left, but that doesn't mean that you can't take left and right turns. So be sure to still take your left and right turns, but reduce lane changes if needed. So it would be best if you're on a highway to maintain the same lane that you're in the entirety of that time, unless you need to get off to do your roundabout to come back the other way. And then in terms of a roundabout, the roundabout must be closed. So if you are going to do it, the vehicle needs to drive around the roundabout in the innermost lane of the roundabout and do a full closure before leaving the roundabout. The collection of overpass requires that each ramp must be collected completely. First, collect along the main line of the overpass in a straight line, and then collect each ramp separately. So in terms of an overall processing workflow that we just went through, now we'll just kind of highlight the uses between our software and the system. So first and foremost, the capture side of it, all of it will be done by the Green Valley app. So you will operate the Green Valley app. You will do your first step is base station setup. So making sure that you're setting up your base station in a very clear area within 20 kilometers of the max extent of the distance for what you will be scanning. If you are to do a scan where you're only able to have a base station set up and the range exceeds 20 kilometers, our software is not capable of utilizing the multi-base station processing at this moment, but if need be, you can utilize something like PostPack to do further multi-base station collections, but we still suggest just using the 20-kilometer range, which should cover most of all urban environments or the need of urban environments during a single days of collection. So then the next step would be the device connection. So making sure that the device is powered on and connecting to the system correctly. Then the next step after that would be the initialization, which I had mentioned, making sure that you choose areas that are very clear, very open, and have 0 to minimal GNSS coverage that has been strewed by trees or anything of that nature. Then you'll start the collection via the device, do your data collection as normal. You'll stop the recording. You'll do that final INS alignment, and then you'll power off the device, or you can start from step A to continue collecting onwards. All of the steps in terms of the recording, the initialization, the data collection, it's all viewed on the Green Valley app, including notifications telling you that your INS calibration needs to be done, a timer that indicates how long you need to sit in a static mode, and what you need to do in terms of the best option for an INS calibration or an INS alignment. After that, so once you capture the data, you will go ahead and move to, sorry. So As mentioned, base station setup. The base station needs to be set up at known points, and the requirements are as follows. The ground foundation is stable, which all surveyors should know that very well. Making sure that the device is not knocked over, so setting up cones to make sure that people don't tamper with the system is always suggested. The field of view is wide, so an elevation angle of obstacles around the field of view should be less than 10 to 15 degrees to ensure that the reception of satellite signal is not affected. So horizontally, you want to make sure that the field of view is that there's nothing lower than 10 to 15 or higher than 10 to 15 degrees of the system. There should be no objects that strongly reflect satellite signals nearby. Stay away from high-powered radio transmission sources when setting up your base station, such as TV stations, radio stations, microwave stations similar to airports, and the distance should not be less than 200 meters. Stay away from high-voltage transmission lines and microwave radio signal transmission channels, and the distance should not be less than 50 meters from those. And the base station range must completely cover the measurement area. As mentioned, the maximum distance of the base station should not exceed 20 kilometers to ensure accuracy. The base station time must completely cover the measurement time exceeding 15 minutes before and after. This is a big thing that you want to follow in case that your base station is not collecting before you start the initialization process, leading to an offset in what the system sees and what the base station actually is recording in terms of satellites. And then choosing a base station that is compatible with multiple frequency bands, such as a 3-star, 7 frequency, or a full frequency. LiDAR360's MLS LiNav, this is the suggestion I gave before, only supports single base station solution process, and multi-base station data needs to be processed with the help of something like IE software, which is Inertial Explorer. So in terms of some of the data collection notes, sudden braking is prohibited, which means it is suggested that you do not do sudden braking, and sudden stops and movements are avoided. Obviously, we do not want you to get in a car accident. We do not want you to injure or endanger yourself. So if the need for you to slam on the brakes while collecting is the number one priority, please do so. It will not damage the system. It will just potentially impact the data quality. So if there is a situation where your driver has to slam on the brakes, make sure that you note to them that they need to tell you of this in advance, because you may need to recollect that data. So it may be best to recollect it right away instead of finding out a couple weeks later when you're going to do processing that you may have had an issue there. Minimizing the number of stops while driving. So one of the situations in terms of traffic, like I said, you can turn on and off the data collection, which would be turning off the data. So the point cloud itself being produced and also the camera data, but you can't turn off the trajectory. So it would be best to eliminate the number of stops. So it is suggested not to collect in high traffic times. So during commute hours is not the best time to be collecting data. And then when you need to pass through a tunnel, it is suggested that you should speed up. This is only just to cover as much of the tunnel as possible in as little time as possible. And then after the acquisition is completed, make sure to click the shutdown button on the app interface first, and then wait for the device to shut down before disconnecting the power supply. Do not turn off the power supply directly, as this abnormal operation will cause data loss, very similar to your laptop or old PlayStations or things of that nature, where if you were to just unplug the power, you may have that issue where you are unable to use the system right away. Afterwards, same situation inside the M2, there is a computer itself. So we want to follow those operations as if you were working with your standard computer. Do not unplug or plug the data collection disk while the device is connected to a power source. So it is suggested to turn off the device before removing the storage drive. And try to drive at a constant speed throughout the data collection time, and maintaining a constant speed of 40 kilometers is best. So for those in the West, it's 25 miles an hour. This is your typical driving speed for urban environments. So it is okay if you were to drop down below that if you're in a residential neighborhood, because again, we do not want you to take the risk of endangering anyone who's walking on the streets or anybody who is out and about. And then be sure to perform the IMU alignment operations as suggested by us every single time the same way. This leads to the better accuracy, the better result in the data, and less need for having to go back and recollect later. So as mentioned before, in the past, the LiMobile M1 required our LiGeo reference software to do the pre-processing, and then moving to our LiDAR360MLS software for post-processing, feature analysis, asset extraction, and etc. Now it's all in one. The point cloud feature intelligent extraction and analysis software is also our pre-processing software as well. So it enables a one-stop data processing to deliver industry results and do your extraction all within one software, making it extremely easy. So the processing workflow is as stated. So a new mobile project. So you're going to take the data from the device. So data copy and raw data quality check and new live scan project. These are all formats that are set up within our system that once you hit start collection on the device, it creates a subfolder based on that day, that time, down to the minute for the use case of that project, keeping everything within that single project folder, making it extremely easy to pull off and put onto your local computer. It'll allow you to run data quality checks such as trajectory jumps inspections, point cloud layering inspections, and absolute accuracy inspection, image overlay display inspection. All these can be done with inside of the software. And the parameter settings such as POS, process, georeferencing, strip adjustment, and output. This is all done still with inside of LiDAR360MLS. And then if you have GCPs, doing control points can be used to participate in that strip adjustment at this point in time. If you want to do it later, you can do it later as well, but it would be suggested to do these at the same time so that you don't have to do the processing post. One-click data processing, such as the POS process, point cloud process, panoramic image analysis, planner image analysis, strip adjustment, filter, colorize, classify by deep learning. These are all one-touch operation. If you want to do them one by one, you can just uncheck the box if you want to watch as they produce the results, or you can have all boxes checked, click start, and it will do all of them in sequential order, leading to your overall ended LiData file that has been processed, georeferenced, colorized, and also classified and adjusted. And then a one-touch click operation converts that LiData file from the pre-processing to the post-processing, which is inside of MLS as well. And so you actually saw all of these in the promotional video, but it was pretty much just highlighting that we have the functionality to do AI-based pavement detection, damage detection. So cracks, ruts, issues with the road itself can be automatically extracted via panoramic and or point cloud. As the promotional video highlighted, we have AI-based plates and face blurring. So this is an automatic feature that can be done. We have AI-based road marking extraction, so automatically extracting the road markings and vectorizing them into their own shapefile is automatically done and generated within the software. And then AI-based road facility extraction is both via the point cloud and also the images themselves. So extracting road signs, road markings, individual features. Our software has an entire list of objects that we have already trained the software on, but we have also given the ability to our clients that have MLS to do training of our software with their own data, their own features that they are looking to do. So if that's something that you are interested in, we have produced videos on YouTube, and we will continue to produce more videos in order to allow our customers to see these functions as clearly as possible. In terms of using the AI training, it does require a powerful computer, so make sure that you think about that going into it. It takes time and it does take a bit of effort, but at the end of the day, you're getting quality that is based on your own data instead of utilizing the training data that we already have. This is just because we cannot train our data on every single road, every single street, and every single block in the world. But we do take what our clients need and what they're looking for, and we give them the option to do so and do their own training so that the data is as accurate to their own local environment. Now we'll just highlight a couple of industry applications. Sorry, between each slide, it's there's a delay that happens every time, so I apologize. This one's taking longer than the rest of them. So this is just pretty much highlighting, and this was also a video as well, That's not playing. So this is just highlighting some overall tests that we did in Oakland, just highlighting the collection and then the deep learning classification and extraction. Overall project size was around 13 kilometers. This was in the Oakland shipping yard. And the overall goal was this was just to highlight the pre-processing and element extraction into the database. So on the left-hand side, we can see the result from classification with a few auto vector of lane lines and crosswalks. And then on the right was a full video data of the data flying through with deep learning classification results, RGB, and then a blend results between the two of them. But unfortunately, since it's not playing the videos, I will just move on past this. This is another example from our clients in Thailand. So the purpose of the case was a road reconstruction and expansion project. Using the LiMobile system, they collected around 111 kilometers of effective data in around 2.5 hours, just showing the ability of the system itself, both the M1 and M2, the capability of the drive, and then the background capability of GBI as an end-to-end solution. They utilized our data georeferencing software at that time. They did strip adjustment in areas that was needed. So they effectively were able to reduce data errors and achieve amazing data accuracy. Even after multiple repeated scans of the area, the data remains the same in the same position. So if you happen to use a third-party system, know that LiDAR360MLS does have a strip adjustment feature for third party as well that can allow you to clean up your data that you may currently already have if you are seeing any type of trajectory adjustment errors. But the whole point of the M2 system is to make it so that the use case of the strip adjustment is not as necessary, if at all, because of the DMI use and the SLAM use. So another one of our studies was done in Shenzhen, which the city road high precision map with the project scale exceeding around 1,000 kilometers. So roughly about half or the entirety of the city is being scanned and detail oriented with feature extraction and also doing HD mapping for the entirety of all the feature assets, including the road markings, the poles, and power lines and such. This one is just highlighting an operation that we did within Shanghai, showing another high precision HD map with the project scale exceeding 150 kilometers. As we can see that this is mostly highlighting that of a parking structure, parking lot, and highlighting the automatic feature extraction for the lane lines of the parking lot, curbs, road markings, and the individual parking lines themselves. One of the last examples that we'll show is the urban survey, power survey and analysis. So again, a video that was supposed to play. So this was in Hawaii, demonstration road high precision map with a project scale exceeding 50 kilometers. The same purpose of what I showed for the Shenzhen is being highlighted here. So doing automatic extraction of lane lines, sidelines, sidewalks, poles, and more. So again, another example was one that was done highlighting the flexible operation in densely populated urban areas, operations in restricted flight areas, so automatic extraction of several different types of features, a height limit analysis, a clearance analysis, and an analysis report. So within MLS, you have the ability to run a series of simulations based on certain conditions with your LiDAR data, including making sure that objects or trucks are able to make it through or under certain types of buildings or power lines, or if they're able to make it around certain turns, or trees, for instance, if there is trees that may be potential danger points, similar to our LiDAR360 software with collection for power lines. Within MLS, you have the ability to run a danger point analysis, real-time danger point analysis, allowing you to see if there's danger points. That would be power lines that are at risk of a tree fall or a tree damaging the power line itself. All of these can be generated and produced in a PDF file, which can be given to the city management system to make sure that they're going and taking care of these potential hazards as early as possible. to prevent any future issues such as fires or electrification or the such. Another example is a urban power survey and analysis that we did within Victoria, Australia. This was highlighting exactly what I was saying about the encroachment. So we did a LiMobile scan that complete the scanning of about 7.45 kilometers of power lines in just about an hour, and then was able to run the danger point analysis, producing reports for any of the areas that had overhanging trees or any other types of obstructions or encroachments that may lead to issues. And the company in Australia was able to provide it to the local management system in order to get those taken care of as soon as possible. And one of the other key new functions within LiDAR360 version 8 is the ability to pretty much turn a point cloud itself that has been RGB colorized or not into a real world scene that can be put into a 3D graphics generating software for the use for video games, for movies. You can rapidly collect multiple source data, generate component level 3D real scene with one click. So as you can see on the right hand side, we have the entirety of the scene put into a real level 3D scene, supports automated quality inspection, and it supports a model library expansion and customized configuration of model textures with more than 10 model editing tools. And we can also add new functions and features if we don't have those. So if you have suggestions for us, let us know and we'll do what we can to try to add more functions over time. So some of the key functionalities of the system itself, though, when utilizing MLS is for road maintenance analysis, road safety analysis, section analysis. So say you're mounting the system onto a rail or a train or a tram line, you're able to do full section analysis. You're able to detect changes within the rail itself, feature extraction of road markings or rail markings, such as the signs and the towers and the poles. With something like the M2 Ultra, you're able to detect certain deviations in the rails themselves to try to prevent, again, any issues that may arise, such as derailments caused by heated rails or changes in temperature to the rail that may lead to a disabling of the rail itself or a deformment of the rail due to those certain types of conditions. And then again, vehicle passability analysis, making sure that trucks, vehicles, when they move throughout the city, that they can do so freely. When new structures are built, making sure that these trucks can make these turns. So you can run simulations within the software based on the point cloud to do vehicle passability analysis and a plethora of other tools within MLS that we didn't highlight at this time. So overall total multi-industry application coverage. So from left to right, as mentioned, we have our section analysis, vehicle passability analysis, HD maps at a high level, high detailed, railway safety analysis, as mentioned before, holographic digitalization of road elements, getting every single feature, making shapefiles, KML files, DXFs, and more, all within one software. GIS assets such as manholes, towers, poles, benches, all these can be automatically classified and extracted from the software, creating real-world digital twins, road maintenance and analysis, such as the cracks and potholes and rutting, are all features that can be extracted from LiDAR360 MLS when coupled with the Ladybug M2 or M2 Ultra, and then road safety analysis. So detailed road safety analysis, as mentioned, ecological landscape simulation analysis, as well as urban forestry, tree counts, tree locations. Those are all functionalities within LiDAR360 MLS. And then urban power survey and analysis. One of the functions that I didn't highlight is the automatic vectorization of power lines. This makes it much easier in order to vectorize your data. And then the automatic extraction of those power lines as vector files is also one-touch operation, making things a lot easier for the user, saving time at the office, and in turn generating more work or more flow of projects in the future. And just a display of the device over the past 6 months to a year, we have put this device through several levels of tests around the world. The top left, you can see that we took the system out to Dubai and did some tests in Dubai. In the bottom left, we can see that this was in the Bay Area of California, just near Berkeley, our headquarters. And then on the top right, we have some of our clients in Japan and Australia, and then some of our users and clients in Shanghai, which was some of the data that we highlighted earlier. And so we just wanted to thank everybody, for being here, for showing up. We're very, very excited about this system. I personally believe that this is the best product that we at GVI have made. And I do believe that you all will see that as well. If you have any further questions or any inquiries, please feel free to reach out to your regional sales manager. At the end of the day, 2025, our main focus is integrity, satisfaction, and striving for a collective collaboration. We as a company are an end-to-end solution provider, and we want to make sure that our clients know that they can start with us and end with us, and make sure that the results that they get are something that they can stand behind when they provide it to their client or their end customer. So thank you everybody for attending this webinar. And I don't know if we can allow questions directly through here, but again, if you have direct questions that haven't been answered, so you can send questions directly into the chat. Some of my team have been actively answering those questions. But again, if any of those questions are not answered, or if you have future questions, please feel free to reach out to us. We don't want to leave you hanging, so let us know what you have in mind. And if you have suggestions or also specific use case needs, feel free to reach out and give us a very detailed explanation so that we can best suit your needs and best help you in the future. Also, I forgot to mention that, as you can see, there's a brochure scanning, a QR code for scanning the brochure. And also we will be posting this to YouTube, likely either at the end of today or tomorrow. So it will be available there. And also any further brochures or questions or examples that we have, we will also post to our website. So feel free to visit greenvalleyinternational.com to learn more about us. And if there's no other direct questions, I will go ahead and end the live stream. And thank you again, and make sure you attend the next webinar. We will use the same platform to host some more live events in the coming future. We do have a few other new products that are just released and soon to be released, so make sure you keep an ear out for those. Someone asked about the particular formats. We have a list of those on our website, including the different types of formats for each of the modules. But it's an entire list of 10 to 20 different exports that the system or that MLS is capable of producing. And if there's a particular format that we cannot generate, please reach out to us to see if we can put that into a future patch update. Indeed. And now, if there's no more questions, then I will definitely end the stream.